Hello, math students. Welcome back to Statistics and Probability. This is lesson 9, and it is called Understanding Variability when Estimating a Population Proportion. Our goal for today we will learn the difference between sampling variability with sample means for numerical data and sample proportions for categorical data. The question that I want you to think about during this lesson is, what is the difference between sample mean and sample proportion? All right, so we have been doing quite a bit of research on just trying to understand all of the different terminology that is being used with collecting data and distributing it and displaying it and understanding it. And so now we're going to add some more info to it. Way back in 6th grade, at the very beginning of statistics, you learned about statistical data being gathered from questions, and they happen to be statistical questions. And there were two types of data that you could collect. You could collect numerical data, or you could collect categorical data. Well, that's exactly what we are going to be talking about, we are going to be talking about the difference between numerical data and categorical data when you're trying to achieve samples from both. And you have spent a ton of time working with collecting numerical data, putting it onto a sample mean dot plot. So remember, you took your data, you found the mean, and then you put it on the dot plot with all of everybody else's data in the class. And then we talked about the sampling variability that resulted because of those dot plots. Well, now we're going to focus on doing that exact same thing, except for this time we're going to use categorical data instead. So under the things to know, we've been working with sample means and determining the sampling variability. This data was representative of numerical data. What do you do when you must determine the sampling variability of categorical data? Well, basically, the answer to that question is that you have to figure out what is your sample proportion. We use sample proportions to accomplish this. And so the next thing that I want to ask you is, how do you decide if data is categorical or numerical? And we spent a little bit of time with this in 6th grade, but we haven't really revisited it. So we're going to just do a quick review of how you decide if data is categorical or numerical. Check out these statistical questions to see if the data is categorical or numerical. So basically, you're just telling me categorical or numerical. Okay, how many hours of sleep do 7th graders get on a night in which there is school the next day? Well, for me, I would immediately say that that's numerical because the data that you're actually collecting is numbers, because it says how many hours, and hours are represented by numbers. So for me, I would say that that one is numerical data because you're dealing with how many hours, so that means that it's numerical. Okay, let's look at the next one. What proportion of the students in our school participate in band or orchestra? Well, for this one, what you're trying to find out is you're trying to figure out, are the students of our school in band? So we have all the students in our school, but how many of them are in band? And then the other option is you're trying to figure out how many of them are in orchestra. And so what we do is we write what I'm writing, which sets up the proportion of what you're comparing. So you're comparing all of the band students to all of the students in the school, and then you're comparing all of the orchestra students to all of the students in the school. And so this is actually what you're going to build your data from, is you're trying to figure out the proportion that represents the specific type of students. And so for this one, we would have to say that it's categorical. And the reason why it's categorical is because it's asking you to set up the proportional rate of band students to regular students, orchestra students to regular students. So that is categorical data. Using numbers is numerical, using proportions is categorical. Okay, so that's pretty helpful to help us figure it out. Next question. What is the typical weight of a backpack for students at your school? The typical weight of backpacks is usually collected in the form of a number. So you got it. That one was easy, numerical, right? And then the last one for us to practice is, what is the likelihood that voters in a certain city will vote for building a new high school? It says, what is the likelihood? It doesn't say how many. It says, what is the likelihood? So what we're going to have to do on that one is that we are going to have to build a proportion. What is the likelihood that voters in a certain city will vote for building a new high school? So what we would compare is to all the voters, right? But we will actually want to put the information that we're seeking, which is new high school. So they will vote for a new high school. And so this would be the proportion that we're looking for, is the voters that will vote for the new high school compared to all the voters who actually vote. So again, since we're building a proportional situation, we would call this categorical. Okay, so those are 4 questions that should have jump-started your thought process in trying to figure out what is the difference between numerical and categorical. And I think it just takes practice to help you figure it out. So basically what we're doing is we know how to deal with the numerical side. So now that we know how to identify that a data set is seeking categorical data, we now can talk about, well, how do we work with categorical data? So in order to be able to plot a sample proportion instead of a sample mean, because means are based off of numbers, a sample proportion, you must create the proportion that will show what you are comparing. So the first step in creating a sample proportion is you have to know what your two comparisons are. So let's try it. We want to sample the 7th grade students of SMS for a number of dogs compared to students. So basically, you're going to walk around Sunala and you are going to find out what pets do students in the 7th grade of Sunala have. And we're going to ask them in sample groups, okay? And the reason why we're going to do sample groups is because it's easier to get our data when they're all organized in a specific class, like you experienced when you went around to all the different classes and you collected your data. So we have the proportion that we want to identify is the number of students who have dogs compared to just all the students in the school. Okay, so that's our proportion. And we have a couple of different interviews that we did. So it says we interviewed 32 7th grade students from our math class. This is how many pets 32 students have in their household. The results are bird, bird, cat, bird, fish, fish, bird, cat, cat, bird, dog, fish, fish, dog, fish, 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 bird, 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 cat, cat, fish, dog, cat, fish, dog, cat. Now that was just in our math class. Okay? So then what we have to figure out from this survey that we took is we have to figure out what is the proportion of dogs to all students. And so basically in this problem set, all students that we have would be 32, right? And now we need to go back and figure out how many of the students in our class of math have dogs. So when we see dogs, we're going to count. So bird, bird, cat, bird, fish, fish, bird, cat, cat, bird, dog, that's 1. Bird, dog, that's 2. Fish, fish, dog, fish, 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 fish. Oh, bird, 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 cat, cat, fish, dog, cat, cat, fish, dog, cat. So I got 5. I hope you got 5. So the proportion that represents this categorical data is that we have 5 out of 32 kids have dogs, okay? So since our proportion that we're looking for is dogs to students, then we can say that 5/32 is the sample proportion, okay? And one of the other things that we have a tendency to do is to take this ratio that we have and turn it into a percent. And then you would show that percent, or even just a decimal, on the display that we're going to choose. But I'm going to stop because I'm getting ahead of myself. We're just going to leave it right now. there are 5 students out of 32 that have dogs in our math class. So then we went and interviewed 32 students in 7th grade from a PE class. So we went to the PE class and we asked the same question. This is how many pets 32 students have in their household. The results are bird, dog, dog, cat, fish. Oh, cat, bird, fish, dog, fish, cat, fish, bird, dog, fish, cat, fish, cat, bird, dog, cat, dog, fish, cat, dog. Sorry, I'm reading fast. So again, our proportion is the same because we're collecting the same data, the same information. What is the proportion of dogs to students this time? Well, we know that our students is still 32 because the class that we interviewed happened to be 32. And now we have to go and count only the results of dogs. So 1, 2, 3, 4, 5, 6, 7. So there were 7 out of this class. So 7 out of 32 in the PE class own dogs. Okay, so let's see the next class that we did. The next class that we interviewed, then we interviewed 32 7th grade students from an art class. This is how many pets 32 students have in their household. The results are dog, dog, cat, dog, bird, cat, bird, fish, cat, bird, cat, bird, cat, dog, fish, dog, cat, dog, fish, cat, fish, dog, bird. Okay, so again, we know that the number of students, we got lucky. There were still 32 kids in that art class, and now we have to find how many had dogs. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 32 in the art class had dogs. Okay, so again, we did the interview again, and this time we interviewed 32 7th grade students from a social studies class. This is how many pets 32 students have in their household, the results. Okay, so I can go ahead and set up our proportion because, again, we have 32 students, and we're looking for dogs. You guys are getting the picture, so we're going faster. So cat, fish, cat, dog. I'm going to count as we go. Fish, cat, bird, cat, dog, fish, cat, bird, dog, fish, bird, cat, dog, fish, cat. So I got 7. I hope you got 7. Let me try it again, just to be quick. Let's see. 1, 2, 3, 4, 5, 6, 7. Yeah, so I got 7 again. All right, last time we interviewed. Then we interviewed 32 7th grade students from an English class. This is how many pets 32 students have in their household. So again, our denominator is 32. The results are cat, fish, cat, bird, fish, cat, fish, cat, bird, cat, dog, fish, cat, dog, fish, bird, cat, fish, dog, fish, cat. Okay, so now let's count the dogs and see what we get. None yet. 1, 2, 3, 4, 5, 6. Got 6 on that one. Okay. All right. So there we go. We finally collected 5 different samples of 32 kids. So it says, how can we show the 5 different proportions in order to analyze the data? Well, can I write all of them on the same page? That would be the first thing that would be really helpful. So in the math class, we had 5 out of 32. In the PE class, we had 7 out of 32. In the art class, we had 8 out of 32. In the social studies class, we had 7 out of 32. And in an English class, we had 6 out of 32. Okay, so that is our proportional data that represents dogs per student. And so it's asking us how we could show the 5 different proportions in order to analyze the data. It says right here, you can create the value of a sample proportion by taking the successful number of does to the total number of, that's supposed to say dogs. Woohoo! Good job, Mrs. Nelson, fast typing. Total number of dogs to the total number of students. this will create a percent, and the percent represents the sample proportion. The percent is then graphed on the dot plot. So we can either leave it like this in fractional form, we could turn it into decimal form, or we could go ahead and turn it into percent form. I will accept all three types because basically they all are equivalent of each other, and you have to somehow represent them. So the way we are going to represent them is we're going to graph them on a dot plot. So we have to decide what we want our dot plot to have. And for the sake of not knowing how to display percentages on a dot plot yet, let's go ahead and turn them into decimals because I think that's going to be the easiest way to show them. And because you're in 7th grade, you're allowed to use a calculator. So Mrs. Nelson is going to use a calculator also. So here's my calculator, and the first one we have is 5 divided by 32, and I get this decimal point here. So we'll talk about our answers when we get them all. 7 divided by 32, it is this guy. Okay, let's do 8 divided by 32, and we get this guy. Okay, and then we have 7 again, so we already have that one, 0.21875, and then we have 6 divided by 32, and we get 0.1875. Okay, so these are these proportions represented in decimal form. And so I'm looking at what would be the most simple way to really look at this, and let's say that let's round everything to the nearest hundredth. So this one rounded to the nearest hundredth would actually be 0.16. This one rounded to the nearest hundredth would be 0.22. This one already is to the nearest hundredth. This one would be 0.22 again. Oh, because they're exactly the same, sorry. And then this one would be 0.19. Okay, so that is what we are going to graph on our dot plot. So we're going to take those values that we have from each of the classes. Remember, this was math. This one was PE. This one was art. This one is social studies. And this one is English. Okay, those are our 5 sample proportions. Got those down. So then we're turning them into a dot plot. And basically, kiddos, you do the same thing that we've been doing with our dot plot data. So let me grab a different color and we'll make our dot plot really quick. So here's our dot plot here. And if we're looking at our ranges of what to include, we have 1600ths, 1900ths, 2200ths, 2200ths, and 2500ths. So I'm saying let's do 1500ths to, let's go ahead and do 2500ths. So it would be 16, 17, 18, 19, 20, 21, 22, 23, this is what I always do, I'm so sorry, 24, and over here on the end is 2500ths. Okay, so I don't know why I always do that, but I fall off the page. So we have one data point at 1600ths. We have 2 data points sitting on 2200ths. And we have 1 data point at 2500ths. And we have 1 data point at 1900ths. Okay, so that's our dot plot. And we've got that going for us now. Okay, so that step is done. So the next thing that it tells us is after we make the dot plot, then we take a look at the data. So you've got to remember all of these data points that are on here, these data points are called sample proportions. And the reason why they're called sample proportions is because they are the ratios or the proportions that are representing the proportion of dogs to students in the 5 different sample classes at SMS. So that's what those are. First question that they ask you to think about when you're working with the data from a sample proportion is, what is the shape of the distribution? So remember, the way that we identify the shape of the distribution is we start on this side, come up, and then go down. So if we're looking at this and we could extend it, I would say, since this is the endpoint of the data and this is the input of the data, what would we say about that data? Remember what it's called. It starts with an S. So I'm going to say it's not symmetrical. I'm going to say that it is skewed. And which is it? Skewed left or skewed right? Who remembers what the definition of skewed is? And this is taking us way, 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 way back to 6th grade. I'll give you a hint. You need to look at the tail. So where is the tail of the data? It's on the left-hand side, which happens to be closer to 0. So we're going to say this is skewed left. And the reason why we're saying that skewed left is because the highest variability is away from 0. Okay, and when I'm talking about highest variability, I'm talking about the highest point of our shape. And so skewed left means that the highest point or variability is farthest away from 0. So that's why that's called skewed left. Okay, what is the variability of the sample proportions? So if you're looking for variability in the actual description, what I want you to remember is variability is how your dot plot looks. And so do we have them spread out or do we have them clumped pretty close together? And so for me, if I was looking at that dot plot and we have 5 data points and they are pretty spread here and spread the same distance to here, then we have 2 of them exactly close and then spread the same distance even though the size doesn't look the same. So I would say that your variability is pretty high. So I would say high variability, and I would say high variability because the data points are equally spread out, are equally spread out. There's not a lot of clumps. Okay, and so remember we talked about where there's a lot of clumps, then that means it's low variability, but when you don't have a lot of clumps and things are spread out pretty evenly out, then we call that high variability. Okay, so that's helpful for us. And then it says, what do you think the population proportion would be? So remember, each of these data points actually represent their own individual samples, because they were the samples of 5 classes at SMS. So what do you think the population proportion would be? And then I would say, for me, I would say that the population proportion would probably be 0.22. And the reason why I would say the population proportion would be 0.22 is because that's the highest point on our data, but this data only represents 5 out of the, I don't know, how many classes do we have at Sunala going at any one time? We have a lot. We have at least 50 to 60 classes going at one time. So, and this is only 5. So I don't know if we could even say that our samples do justice for the whole school. So what do I think the population proportion would be? I would say that 22/100ths or even 22% of our school has dogs. That's what I'm trying to say, is that 22% has dogs. So it's kind of interesting because a lot of this is just really going off your samples and seeing if you think that they are a good representation. And that leads us to the next question. Do you think that your sample variability, because remember, the dot plot is the sample variability. Do you think that your sample variability significantly represents the proportion for the population? And I don't know if I could say yes. I don't know that I could say that it significantly represents our population proportion because it's 22%. And then if you look at this, we figured out that in the math class, it's only 16%. In the PE class, we discovered that it was 22%. In the art class, it was 25%. In social studies, it was 22%. And in English, it was 19%. So, you know what? Looking at those 5 samples and all of them being right around that area, maybe it is. So I'm going to say yeah. Okay, yes, because all sample proportions are very similar in size. So yeah, that's going to be my justification for the yes. Okay. So remember how we've been talking about in class that this really is based on what is your data and what you're using it for. If you can justify your answer, I will listen. Wholeheartedly, I will listen. Okay, now that we know how to find sampling variability from numerical data and categorical data, the difference between the 2 types of data is numerical data uses sample means. Okay. Categorical data uses sample proportions. Okay, and the reason why this is true is because with numerical data, you have the numbers, so you can find the means. With categorical data, you don't always have the numbers. You have amounts, but you have to figure out what is the proportion or what is the ratio of whatever you're looking for to the total. And so categorical data uses proportions to figure out what the representation is and then graph those. Okay? So there are 2 very different ways to collect data and display them, but you have to be able to look at the data and understand what it's trying to tell you. So going back, I'm so sorry this lesson has taken a while, but I think we learned a lot. Going back to our goal, today we will learn the difference between sampling variability of sample means for numerical data and sample proportions for categorical data. I can wholeheartedly say that I really believe you know the difference between numerical data and categorical data after this lesson. What is the difference between sample means and sample proportions? Sample mean is that you can actually find the mean of all the numerical data because you have the numbers. Sample proportions, you only have the words because that's what categories are, and you have to turn those words into a proportion so that you can find the numerical data that the words represent. That's the difference. All right, kiddos, that's all I have for you in this lesson. Thank you so much for working hard and learning new stuff. I'll see you all tomorrow. Bye.